Unsupervised learning is a type of machine learning where the model is trained on unlabeled data, meaning it doesn't have explicit input-output pairs. Instead, the algorithm identifies patterns, structures, or relationships within the data on its own. Unsupervised learning works with raw data without predefined labels. Unlike supervised learning, there are no correct answers provided. The model finds patterns by itself. Pattern recognition is a core idea in unsupervised learning. The algorithm groups similar data points together based on hidden structures. Structure identification helps discover underlying patterns within the data, like clusters or hierarchical groupings. Relationship discovery finds meaningful connections between different data points. This is used in market basket analysis, where we learn that people who buy bread often buy butter. Self-organization refers to the model's ability to autonomously organize and categorize data into meaningful clusters or structures without explicit instructions. K-means divides data into K-clusters by minimizing the variance within each cluster. Hierarchical clustering creates a tree-like structure of nested clusters. DBSCAN groups dense regions while marking low-density points as noise. Mean shift moves data points toward the densest region in feature space. Gaussian mixture models use multiple Gaussian distributions to model clusters. Agglomerative clustering starts with individual data points and merges them into clusters. Optics is similar to DBSCAN but allows the identification of clusters with varying densities. Principal component analysis transforms data into principal components that maximize variance. T-SNE projects high-dimensional data into a lower-dimensional space while preserving local relationships. UMAP preserves both local and global structures better than T-SNE. Autoencoders compress input into a lower dimensional representation and reconstruct it. Factor analysis identifies latent variables that explain observed data variability. ELDA finds discriminative features in unlabeled data. A priori algorithm identifies frequent item sets in transactional data using a breadth-first search. ECLA algorithm is an efficient depth-first alternative to a priori that uses intersection-based counting. A growth algorithm builds a compact tree structure to mine frequent item sets efficiently. Isolation forest isolates anomalies quickly by randomly partitioning data points. One class SVM learns a boundary around normal data points to detect anomalies. LoF assigns anomaly scores based on how much a point deviates from its neighbors. SOM maps high-dimensional data into a lower-dimensional space while preserving similarity. Relationships. Hebbian learning strengthens connections between neurons that activate together. Spectral clustering uses eigenvalues of the graph Laplacian matrix for clustering. LUVM algorithm detects communities in large networks by maximizing modularity. SVD decomposes a matrix into 3 matrices, capturing latent features. NMF decomposes a non-negative matrix into 2 lower-rank matrices. In this unsupervised learning series, we focused on key algorithms such as clustering, dimensionality reduction, and other essential techniques. This was a high-level overview, and each of these algorithms can be explored in more depth individually. I hope you found this video helpful. If you enjoyed it, please give it a thumbs up, subscribe to the channel, leave a comment, and share it with your friends. Your support means a lot. See you in the next video.